Good evening, sir.
Good evening, Murali.
Yes. So we'll wait for others to join. I have posted in the group also.
Sure.
Okay, we'll start. So we have completed storage and storage lab also. So now we are coming for the eighth module. That is the last important module. As I told, like fourth, fifth, sixth, seventh, and eighth are the important modules. Now data. What do you know about database? What is meant by database? Do you know the types of database? Yes.
No, no.
I think
No.
SQL, MySQL.
Okay. There are two types of databases. Okay. One is relational database and another one is non-relational database. Okay, so relational database is nothing but your SQL. Non-relational database is your MongoDB. Okay, that means SQL represents what? Structured query language. Structured query language. That is, it'll have a structure like table, rows and columns. I have to arrange the data in the rows and columns only. Here it is unstructured. I can able to arrange the data either structured also or unstructured way. There are other much differences are there. That why we call this as relational database. Why we call this as relational database? Now, why we are calling this as relational database? Let us take tables. Okay, let us take this table one. Variable C table one. Here we have name, email ID, phone number. And again, here we are setting this as the primary key. That is the employee ID as the primary. That means the employee ID should be unique because names might be same. Same names can come again and again. So employee ID should be different. So employee ID should be unique. Wherever I want to make my ID as unique, I can have it as a primary key. Now this is for table one. This is a primary key. Now table two, we are mentioning we are having address and phone number. How we are connecting this employee's address and phone number here with the help of employee ID, same employee ID. Now when we go for the table which we created first, we have primary key. Now same column, that is this column is connected to another table. Now there it will become foreign key. There it will become foreign key. That means this column is depends on this one. This column is depends on this table one's primary key. That is employee ID. Now from these two table, there is a relationship. That is nothing but main relationship is mainly connected because of the employee ID. Now if we go, we can able to derive another table also. We can able to derive another table. That is from these two table, I can create one more table. For example, here I mentioned a derived table number 3, where I take the employee ID because it's a common. Now again it will become a foreign key. Why? Because this is not the main table where I take the employee ID from. I took the employee ID from the table 1. So there it is primary key. Here it will become foreign key. Now I take the column name and email ID from this table, table 1, and take the table 2's pin code column alone. That is from these two tables I am deriving another table. From these two tables I am deriving another table. So now there is a relationship between all these three tables. So relational database why? Mainly we are saying as relational database. And how can we identify that this is they have created using uh, relational database, that is structure. So wherever you go, wherever example, the best example would be your credit card or debit card statement. You're getting your credit card debit card statements, right? In that, what are the details are there actually? Let us take credit card itself. What are the details are there in that statement?
Bank account detail, and in the sense
Yes,
card
bank
detail.
account. That means your name will be there, your bank account or the card number alone will be there. Credit card means,
Ah,
and it'll show you the statements. Correct?
yes,
That too from for the 3 months or the first month. That month alone statement will be there. But when you
correct.
open the bank account, you have given some 30 informations maybe your name, phone number, email ID, where are you staying, where is nearby, your PAN card number, Aadhaar card number, everything you have given, nominee, around 30, 25 to 30 statements you have given, I mean details you have given. But not all these data are printed, correct?
Yes,
So now this is your main table. Now for this credit card statement, I want only little information. Okay, this is your main, your personal details or the bank holder details, bank customer detail, main bank customer details. So from this table, I'm able to take some data whichever I require to derive another table. And in the format also, you can able to see in the the credit card statements that it is having like a tabular column. Correct now the structured one. So wherever there is a structure, you can easily understand that this is they are using a relational database in the backend. When there is no structure, there is no structure. That means, for example, here this is structure because I have mentioned employee ID, name, phone number, email ID. Can I insert a picture here or a video here?
you can.
You can. I can able to give a link. Correct na? I can paste the link.
Yes,
If I insert the picture again, this will get distorted. The size will not fit, and a lot of other issues will be there. correct? So normal, let us take your bank account. Your bank account is your, or banking application, let us take, is your relational database. And non-relational database, let us take your Instagram database. If Instagram, can we able to update the text? Yes. Photos we can post, videos
Yes.
we can post, various types, different sizes also we can able to store. Correct na? So now there is no structure. I don't have any structure. And what is a plus point? What is a plus point in non-structure means? For example, in the structure, if I created a table like this, for example, name or user ID, name, email ID. Now I have already entered some five data. So let us take, I have added some five data. I have already added. Okay. Now after some time I want to add one more field like age I want to add. Now what will happen? I cannot able to add the structure because already 10 data or 5 data have been entered. Now we cannot add one more field. If I want to add one more field, I have to create a new table. I have to create a new table, that is rows and columns. Then only I can add. But here this is SQL. That is relational database. We cannot able to change it once we create it. If you want to change it, then you have to move the entire data again and again to the other table. But in the non-SQL, if you have already added some three fields, and after some time you try to add one more field, yes, you can add it, but the data will come from here only. Let us take, already these columns are filled 1, 2, 3. Now this one is a fourth one, but fourth one you added one more column. Now fourth one alone you'll have this data. All the other three will be empty. That is, it will accept no structure also. No structure also. Okay. So you should know the difference, mainly the difference between a relational database and non-relational database. Okay. So for that I have already created main thing. Maybe if you have a note or something, you can write and keep it. It will be helpful for wherever you go for any interview also. What is the difference between SQL and no SQL, or relational database and non-relational database? So main difference is the data arrangements. Here in the structured, that is SQL, you'll be having rows and columns like your Excel sheet. Best example would be your Excel sheet is your relational database, because you can see rows and columns. There in the non-relational database, it will be key value. Key value means nothing but name. Name is to Ramesh. Now this is key and the value. This is called key and value. Next, one person's data in the SQL, we call it as a record or tuple. Here we call it as documents or items in the non-relational database, that is NoSQL. Now here in the SQL, images files we'll be storing as a link, as just now I told you. But here in the MongoDB, we can able to store the images directly also, will be visible. When it comes to the structure, in relational database, we have a fixed structure. Just now I told you, I draw and showed you. That's a fixed structure. Here it is no fixed structure. It can be able to edit it. You can able to extend the schema, change the structure also later. Next, scaling. Scaling means increasing or decreasing. Here it is vertical scaling. That's why I told you it's the best example would be Excel sheet. Now horizontal scaling. When it comes to non-relational database, it is horizontal scaling. Horizontal scaling means struts. What is mean by this struts means? Let me just explain you. So before I go into this database concept, I just want you to clearly understand what is SQL, that is relational database, and non-relational database. That's why I'm just explaining you. So let me come back here. So as I told you, SQL we have vertical scaling. That is, it will go keep on go beyond. Like, have you checked your Excel sheet? How many rows will be there? Have you ever checked, or do you know how many rows will be there? Hmm.
Is it around 1 million something?
No, no, 1 million.
10 lakh. I think.
10 lakh.
That's
Huh?
the same.
You can open your Excel sheet if you're watching from laptop. You can able to check it. I think 10 lakh.
It's
No.
10 lakh 48, 10 lakh 48,
Mhm.
576.
Okay, 10
Yeah,
lakh
that's
38,756. Okay.
yeah.
No, that's the limit. Correct. No, that is your limit. That is for your Excel. So there is a limit. There is a value. That is your SQL. There is a value. But no SQL, there is no limit. No SQL, there is no limit. And now I just now told you scaling, it is vertical scaling. Why? Because Excel sheet will go vertically. You're able to see that. Na? We keep on entering down, 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 down. We keep on entering. So that's why you have 10 lakh lines. Now here it is threads. That is, it is horizontal scaling. Horizontal means like this. Now what is this? How they are splitting this means, for example, you have 1 lakh data. You have 1 lakh data, and you want to find a number called 25532. This value, this data you want to fetch from this 1 lakh data means, what you will do, you will search for this. Correct? Now you have to write a SQL query. You have to search for this. Now what will happen, 25532, it will go and search in the database. It will go and search in the database. So it will take some time, right? Because it's 1 lakh data is there and your point is 25,532. It will take some time. Now how can we reduce this time? Now that's where they are using the strud concept. Strud. What is the strud means? Now this 1 lakh I am dividing into two tables. One is odd numbers, another one is even numbers. Now when I type this number to search, which table it will go and check? 25532
Even.
even. Correct now? Now even number will have again 50,000 data only, because this 1 lakh only we split it. Now which one will be faster? Searching in the 1 lakh database is faster, or searching in the 50,000 database is faster? That too we have
50.
already started to even number 50, right? So that's why people are saying that no SQL is more faster. No SQL is more faster than SQL. So it will reduce the time. Okay. Now that's what I showed you there. And coming back to here.
So does that mean we store lesser data, or it is like we store only the relevant data?
No, here we split into relevant data.
Okay. Only even, only odd.
One event. That's what it's our wish only.
Okay.
By default, it will try to split when we enter the data itself. It will split into struts so that the query can be retrieved faster.
Okay.
Okay. Yes. Now here in the SQL query, what is here means, here we have to search the answer. We have only one option, that is search query. That is SQL query. Like in your search box, like in your Google, you are going and typing it search box. And whatever websites or database you have only one option called search bar will be there. In the search bar, you will go and type. That is one option. That is only one option we have in the SQL. But here in the NoSQL database, we have two options. One is same SQL query, and another one is scan. Like your TV remote, you have TV remote, right? Now SQL query is nothing but like you want to go to the channel number 1508. What you will do?
I'll
What you will
hard
do?
code.
Yes, we have to search in the type. Correct, na?
Yes.
We have to type it in the remote directly 1508. Now immediately it will go to that query. I mean, immediately go to that particular channel. Now same thing in the remote. We have that option also, and one more option also we have. What is that? Scan option. But what it will do, the scan option will do, It'll go and search everything, and then only at last it will show, and we have to select it. Correct? Na? Same thing only in DynamoDB, that is, I mean, NoSQL, we have scan option also for your querying. Next, coming to AWS, we have RDS and Aurora. RDS and Aurora are the methods types we have in coming under relational database. And here in AWS, we have DynamoDB, which is coming under NoSQL. Okay, so and main example I would say you when you want to remember SQL and NoSQL, your normal banking app, correct? Na? Normal banking app. If you log in, you'll send money, transfer, receive it, pay your credit card, debit card, whatever bill it is. Correct? Na? Will your banking app will be faster or your Instagram is faster?
Instagram.
Yes. So SQL, that is NoSQL, is more faster than your SQL. But SQL is structured. Now banking app will be neat perfectly. All the data will be disabled without having any issues. Instagram, yes, it loads faster, it store the database faster. Okay, fine. I hope you understand the differences. Now let us go inside. You have made a note. So let us go inside database now. Okay, database, as we already mentioned in the compute, I already mentioned in the compute module, database server. What? Database server is also possible. So we'll see that as well. Fine. So in this module, we are going to discuss about RDS, DynamoDB, Redshift, Aurora, and we'll know about the functionality of RDS, DynamoDB, Redshift, and Auroras, and its configuration and integrations. Now, first one, relational database, that is your SQL. Relational database service, as the name itself says, it's a relational database service, but we name this as RDS. Why? Because we are going to use this as a database server. We are going to use this as a database server. Directly server, we are going to use it. Where AWS itself already created a direct RDS service, that is relational database service, where we can directly take and use it. Now, previously, what was the challenges in the maintenance, server maintenance? I mean, in the previous maintaining, the challenges which we have in your normal relational database. Now, the server maintenance and energy footprints, that is automatically we have to manage and maintain these servers. We have to manage software installation and patches work, because when you have a database server, you have to update the server often. Then we have database backups. You have to keep on taking and keeping all the backups, and the database should be always available. We have to make sure that the database is always available. Limited scalability. Just now I told you the Excel as an example. Limited 10 lakh is a limit. So there was some limit for your SQL relational database. And another thing is data security. So data security, we have to put password or protection to all the data. Next, operating system installation and patches. Again, operating system, what you are on what top of the OS you have installed your database, that OS should get updated also. Patches means nothing but upgrade. Patches means nothing but upgrade. So these are the challenges we have when we are maintaining a database, when we are maintaining a database from our end. Now AWS taken these challenges and they are trying to reduce it. How? They're comparing with all these things. What we are doing is called unmanaged service. Unmanaged service means that is we are not able to scale it automatically. We only have to go and scale it. Fault tolerance. If there is any fault, it will not run, and sometimes it is not available because we are managed. This database is managed by us. When we create a database and do it, we have to only go and scale it. We have to find the faults. We have to make sure it is available. Everything is managed by, that is managed by us. Now when it comes to managed service, as we already learned in the lambda, do you remember what is meant by managed service? Serverless means what?
Something like Lambda,
Huh? Uh,
Lambda, which is managed.
manage what is meant by serverless?
So which is managed by AWS.
Yes, exactly. Which is managed by AWS. Now, same thing only. Manager service means wherever we say managed service means you should automatically remember that it is managed by AWS. We don't want to manage. Now, scaling, fault tolerance, availability, everything is built into the service itself, which is managed by AWS. Which is managed by AWS. Now, Amazon RDS is the managed service that sets up and operates a relational database in the cloud, where users come to the application server and application server will go to the database. Now, database can be retrieved again and it will come back to the user. Now, RDS is a managed service. RDS is designed by AWS for this relational database management system. It can be managed by AWS. We don't want to do anything. But RDS is a service. RDS is a server. Server, as we already know about, but will tell you is server, correct? So I think this is a server directly. Server means we should have. So I told him. He said it means server means what?
Instance.
System. System, yes. Good. Instance. Instance means system. Systems will have what? CPU, memory, network, and storage. Everything will be there. Correct? Na? Same thing this RDS server also will have. Now, what is the advantage of taking RDS when we already have EC2 and on premises? On premises is nothing but your physical server. On premises database. Now, on premises database is nothing but your physical database server. Now, in the physical database means who will manage what are the works we have. We have to optimize application, we have to scale, we have to make sure it is highly available, we have to take the database backup, software patchwork, software installation, operating system patches, operating system installation, rack and stack. You have to arrange the rack and stack of your physical server, and also the power and havoc and network. What is in the havoc?
Not sure.
Okay. So when you have lot of system in a room, what you need first of all? From your college lab, you have that. In your office also, you have that. When you have multiple systems, mainly
Space.
what? Okay, one more, closer.
Premise.
No,
Is it racks?
racks and stack. This is what the rack, na. This is the computer I just designed. Okay, computer rack. Now, when multiple systems we have, what we need definitely, the systems will get heat or not.
Yes, yes.
Yeah.
Cooling system,
Yes.
something AC.
Yes. So heat, ventilation, AC, air conditioning. Okay. Power, heat, ventilation, AC, network. Now all these things will be managed by you if you are taking on-premise database. Now we are moving to, we take one of the EC2 server, we are converting that into a database server or using it as a database server, not converting EC2, we are maintaining it as using it as a database server. Now, now if you're taking EC2 as your instance for a database, now what are things you have to manage? Now AWS will manage the operating system patches, operating system server, power havoc, and network. AWS will manage, but the remaining thing, that is application scaling, availability, backup, software patches, database software, database installation, all these things you have to do. Again, there is half work is done by AWS, half work is done by us. Now I don't want to do this also. Then I'll go for directly Amazon RDS. Amazon RDS or Amazon Aurora. In the RDS, we have Aurora also, the other type. Now, here you can see you focus only on your application optimization, the scaling, availability, backup, patches, everything will be managed by AWS itself. So, on premises, no, EC2 also no. We go for RDS. We are going to focus only on our application. All these remaining things will be managed by AWS itself. We don't want to do anything. Same thing. That's why we call this as managed service responsibility. AWS will manage all these things: installation, patchwork, backup, scaling, racking, stacking, server maintenance, everything. We focus on our application only. Now, RDS is an instance. Means I already told you, it's a server. Server will have CPU, memory, network performance, and storage as well. In the storage, we can able to decide which we want, as we already learned the types of storage, because it's a server storage. As I already explained you, like EC2, we have EBS, right? EBS storage. Same thing here. The EBS storage, we have general purpose solid state drive or IOPS. Which one we want, we can able to select it. Now this RDS will support only six database engines. What are those six database engines? One is Oracle, another one is MariaDB, another one is PostgreSQL, and Microsoft SQL Server, Amazon Aurora, and MySQL. Only these things will be taken care by the database management, that is your database engine. Only these six only supported by RDS DBA. Okay, so if you're making a note, you can just make a note. This is six only RDS will support. And as RDS is a server, server will have all these things: CPU, memory, network, and storage. That is our wish. Which one we want, we can select it. Next, RDS in a virtual private cloud. So how RDS will work? Users will go to first internet gateway in the VPC, then it will go to the server, EC2 instance, and private subnet. Private subnet, that is, the database will be stored in your private subnet. Why private subnet? For example, you have a registration page. I think I told you this already in your first class. So your registration data will get stored in the database. Will you give the access to the public actually, the data which you collected? Will you give this data which you have collected where the people, public can able to access this data? Will you allow? Will you allow?
No, will not.
No, right? Yes. So same thing. That's why we put it in the private subnet, as we already told you in the networking lab. Private network, when whatever you put it in the private subnet, public cannot be able to access it. Public cannot be able to access it. Now, how to make it is highly available with multiple availability zones deployment. High availability with multiple availability zone. High availability means what? Your database should be always available. No, there should not be any time where it should not say I'm not available or error. Correct? Database should be able to access. For that, what we do, we have to make sure it is highly available, always available. For that, what we do, we take a copy in the second availability zone of your main database, which is synchronizing and keeping it in the other availability zone. That copy is called a standby copy. That copy is called standby copy. Now, the standby copy is synchronized. What is meant by synchronized?
Synchronous, I think whatever data which we update in the
Mhm.
availability zone 1, so the same will be updated in availability on real time basis.
Yes, but how? How?
Any integration?
No, no. By fast. Okay, fastly it will update. Fastly it will update. Where you have seen this sync in your life? Have you seen this word called sync?
Yes, yes. Which like
Where?
in mobile, like in Gmail or like
Yes,
sync the.
exactly. When you switch off your mobile and switch on after a few minutes or some time, if any data comes, first it will go for the synchronized mode where it will get the updated messages and everything to the phone. Correct, na? Now
Yes.
synchronized means what? Faster update. So when whatever you are typing here, immediately it will get have a synchronized copy here. So people that public first access a server and the application, the data you're entering, the data will go to the database. From the database, immediately one more copy will be stored in the standby copy. One more copy will be stored in the standby copy in the availability zone 2. Availability zone 2. Now this is called your synchronous. For this we have a standby copy. So now the database will not show any error. If this database is not working, immediately this database will get activated immediately. That's what I told you, like why we have 3 availability zone every time. So always you'll have a backup copy by default. One more thing is we RDS is taken by us. Already this is you. Now again one more copy you're keeping it as a standby copy. This will be less cost only when compared to this, but we are creating it. Okay. Now the database is highly available. We have one more option as just now I told, not one more. User able to see if this is not working, the database application will directly contact the standby copy. Automatically, the data people wants to access will be there. Next, one more is RDS read replica. RDS read replica. What is this read replica? Let me just tell you. Now, this read replica is offering a asynchronous operation. What is an asynchronous? Just now we talk about synchronize. Synchronize means what? Synchronize
Faster.
means what I told? Fast. Okay. Asynchronize means what?
Scattered.
Scattered. No. Okay. I'll explain you. We'll come back. Now let us take a visitor is coming to see a CEO. Okay. To see a CEO. The PA is there. So the visitor comes at 9:30. Okay. AM. and the executive, the watchman or the executive says to the PA that one person came, the visitor came, visitor A came and to meet the CEO. So CEO at 9:30 he says, till 12:30 I am busy. I cannot meet anybody till 12:30. Okay, na? He said to the PA. Now what the PA will do? What the PA will do? PA will say to the client, na, to the visitor,
Yes.
yes, that is what she will say. You cannot meet him now. You come after 12:30. Correct, na?
Correct.
Okay. Now one more visitor come B at 10:30. What the PA will do? Will the PA will go to the CEO again and ask,
No,
why?
because already CEO told
Hmm.
to him about his availability.
Yes. So now the PA directly will answer to this B, correct na? Without going
Yes.
to the CEO, correct na? So now this PA is becoming a read replica. That is the application first time it comes. Let us take who is Amir Khan is asking. First time when you contact the application is going to the read replica. Read replica is contacting the database. Now database is answering who is Amir Khan. Now he is replied and read replica get the answer from the database, get the reply and reply to the application. Now second time same question comes, the application goes to read replica. Now read replica will not go to the database because it already knows the answer, so it will reflect immediately. Now the answer is very faster. Yes. Now
Yes.
same thing. The PA, the CEO is not well. The CEO is not well. Can this PA can manage the office? Whatever the CEO do, can he or
No.
she can able to manage?
No.
Yes, sir. No. Yes, right. CEO, whatever CEO does every
So
day, the PA is
whatever
watching.
whatever limited information he has with him, like whatever
Hmm.
day-to-day activities he can manage.
Mhm. It's regular routine jobs. Let us take the PA can able to manage, and PA has been more than 1 year. Let us say 1 year or 6 months. She knows all the in and out of the CEO, what situation, what decision he will usually take. Like we talk about our MD, our staffs, right? Same thing PA can also
Yeah.
can say, right? Yes. So it can able to manage, correct now in the absence of CEO. Same thing, read replica, see here, can be promoted to primary if needed. If needed, we can make it as a primary. Like we learned primary, secondary na, in the lambda function. Lambda function, primary, secondary.
Yep.
Yes. Same thing. This can be promoted as primary. So mainly when we use this read replica means when we have that much data to be answered very faster, then we use this read replica because read replica is again going to cost you. And for RDS, one RDS can have five read replicas. Five read replicas we can able to take it. One RDS can have five read replicas. Just similar to your shop. A shop owner is there. The shop owner can keep multiple salesperson. But shop owner only first time he will know which item is in which location. Correct now, if we go and join in a shop also, we don't know what are the products, where it is. Only the shop owner knows. First time he will teach us, but second time he will not teach us. Correct now. Same thing only. This read replica. Read replica mainly will use for heavy database workloads. Offload read queries mainly most offload means even there is no power. What you'll do? Already the data is stored here. Like how we have our phones, we have video songs, musics, right? Even there is no internet also. Our we can able to watch the video. We can able to read the when we can able to listen to the music. Same thing, offload read queries we can able to answer with the help of read replicas. Now where and
Sir,
all
one
we'll
thing
be
I just
using. Yes.
hello.
Yes,
Yeah,
yes.
one thing I just want to understand, like, what is the benefit for the customer using of read replica instance? So whether it is a cost
Faster.
optimization.
No,
Okay,
no, 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 no cost optimization. You want asynchronous reply. Now, how ChatGPT is taking? Is ChatGPT is taking more time to understand the question, or within 30 seconds or 20 seconds or 2 seconds is it replying?
yes,
So
that it,
2 seconds or 1 second it is able to reply by understanding. See, we are putting a lot of tough questions to the which we don't even understand. We are putting to the ChatGPT, but ChatGPT is giving reply instantly within a seconds of time, that this is a solution, this is what you are trying to say, this is what you are trying to this is what you are trying to do, these are the steps, correct now? That means what?
correct,
Already someone has already asked these questions,
correct,
correct now? It is already having the answers with it. So that's why it is
absolutely.
not even thinking, just it's already the answer is there, I reply faster.
Okay, got it.
Yes. Next use cases. So web and mobile applications we can able to use, like mainly high throughput. Throughput means bandwidth. Massive storage scalability. We can able to store a lot of data, highly available also. And e-commerce applications. E-commerce applications like your Amazon, Flipkart, like that. Low cost database, data security, fully managed solution I want to have. Then I can go with this. Mobile and online games. We can go with mobile and online games, but not very tough games. Not very big games as I told, like PUBG and all. Normal games we can go. Rapidly grow capacity, automatic scaling, and database monitoring. All these are the use cases. See, when to use RDS, they itself recommending you use RDS only when your application requires complex transaction or complex queries. Because when relational databases, multiple tables, multiple relations, when you have complex transactions, as I told for the bank. Now, they also say the medium of high query to read and write operation, that is input and output operations, where up to 30,000 read and writes in a second, you can go. No more than a single worker node or stud, because stud will not support by SQL. I already told you. Stud is only for no SQL. Next, high durability. Durability means long lasting. Database will be long lasting. You can able to retrieve the data faster. It will be long lasting. Now, when do not use RDS, do not use RDS when we have a massive read and write rates like 1,50,000 read and writes, like your temple run. That guy is running, he has to jump, he has to capture the coins, the score has to be updated, everything in a second. Every second it is read and write operation is happening. So those operations we should not use RDS, we go for NoSQL. Setting due to high data size or throughput demands, we don't want to use. Next, get simple in get or put request and queries that are NoSQL database can handle. That was just now I told you the temple run. Get means what? Only read and retrieve data, as we already mentioned. Read and retrieve data. Put means we can able to update immediately. You want to update that, you can able to do it. So relational database management customization, as I already mentioned in the first opening, that SQL cannot take NoSQL, but NoSQL can take the structure of SQL and work. So same thing, relational database customization we can able to do with your NoSQL, that is your non-relational database. Now how we are going to build it? As it's an instance, as it is an instance means what? Server will be charged always in hours. Server will be charged always in hours. So resources incur charges when running only. And database characteristics, as it's a database, it will have physical capacity also. So physical capacity of the database, we first consider the engine, what engine you are using, what is the size, and what is the memory class we are using. All these will have to take into consideration. Database, that to RDS alone will come under both Both means like instance, that is server point of view also and storage point of view also. As we learn fundamentals of pricing, fundamentals of pricing is what? Only three times we will be charging, only three phases on three reasons will be charged. One is hourly basis for your server because it is running 24 hours. Another one is per GB per month for your storage. Another one is per GB per month data transfer. Correct? These three are the main thing for charging. How AWS will charge in three methods only. One is hours, that's for server. Second one is for storage. Third one is for data transfer. Only these three reasons Amazon will charge. Now this RDS alone will come under two category. One is for the server charges, server category. Another one is for storage category. Next, we already know, we have learned about the pricing models. On-demand instance. On-demand means what? Pay for what you use. So that's what on-demand instances. Next, compute capacity by the hours, if based on how much capacity you have used, based on that. Next, reserved instance, we can able to go for reserving your database because database is permanently we are going to use it. So we when we take the server in the month of January, and we have to block that full year only. So better always take 1 year or 2 years so that you'll be able to save money. That too, if you take upfront payment, you'll be getting more discount. Next, number of database instances. Provision multiple database instances to handle peak workloads. That means you can take multiple servers based on the workload. Next, provision storage. Provision storage means when you take EC2 instance like RDS, you have a provision storage service like EBS. That is no charge. That will back up also automatically up to 100% of the database storage. For an active database, they will do the backup automatically. In case you are storing a database, in case if you are storing a database in the S3 bucket, in the S3 bucket, because for the terminated DB means what? The DB is over. The DB we closed it. We choose another DB. Now the old DB will be there. Now that DB backup I want to keep it in the S3 bucket. Now this will be charged. That's what they mentioned. Charge per GB per month. Same thing. Additionally, if you want to take any backup data, we can able to use it. That is also will be charged. Next, the deployment type and data transfer. As I already mentioned, the number of input-output requests that are made to the database. We can go for another method also. Either you go for GB per month or the number of requests we given to the database. For the database, how many requests we are sending. That get method, especially get method alone will be charged. Next, deployment type, we can able to deploy in single availability zone or multiple availability zones so that we can have we can able to get the data faster. Next, to data transfer. As we already know, data transfer incoming call is always free, so no charge for the incoming inbound data transfer. Tired charges for the outbound data transfer as well. Tired charges means category, like one first tier, like your colleges we say, na first one tier one college, tier two college, tier three colleges, like that. How much data you are transferring outside, based on that you charged. Coming to the end of this section, with RDS, Amazon RDS, you can set up, operate, scale relational database in the cloud, manage services accessible via console, command line interface, programming interface application, scalable, that is compute and storage, automated redundancy and backup are also available. So automatically it will redundantly take the backup. Supported database engines mainly like Aurora, PostgreSQL, MariaDB, Oracle, and Microsoft SQL Server. So this is all about your RDS. Now DynamoDB, which is nothing but NoSQL, which is nothing but NoSQL. It's we'll finish this one. Just a small slide only. As I already explained you multiple things about this SQL and NoSQL. SQL and NoSQL. You are able to see that. As I already mentioned, data storage, here it is rows and columns, here it is key and value pair. Here we call it as documents or graph. Here it is, we call it as rows, records or tuple. Here the schema is fixed, here it is dynamic, it can be changed. Querying, we can use SQL here, it focus on data collection, it is like MongoDB. Similar to this, we call it as documents. And then here, as I mentioned, SQL it is vertical, and here it is horizontal. Now, here it is vertical, here it is horizontal scaling. As I already mentioned, it is going to have struts. Now, here is the best example, as I told you, key value per key value, key value. It will be in the JSON format. It will be in the JSON format. That is non-SQL. And best example for SQL is your Excel sheet. As I told you, you will have this Excel sheet format like your book ISBN, title, author format. Now, what is Amazon DynamoDB? As I told you, it is a fast and flexible NoSQL database service for a scale, and it is having unlimited storage. As mentioned previously, SQL we have a limitation, but NoSQL we don't have any limitation for storage. Virtually, database tables also multiple tables we can create. Items can have their different attributes we can able to add. Low deliveries. Scalable, so you able to get the data very fast. As I told already, the example of your banking app and Instagram. Amazon DynamoDB core components. What are the core components? So DynamoDB mainly will have tables. As I told you, tables, items. Items is nothing but one value, one row, key value. Core DynamoDB components. Attributes are nothing but the name, email ID, phone number, age, address. All these are called attributes. Items is nothing but this one. The entire row is called as attribute. I mean items. Here we call it as items, and there in the SQL we call it as records. DynamoDB supports two different kinds of primary keys. One is partition key and sort key. Partition key and sort key. What is this partition key and sort key? Let us say your college attendance is there now. Colleges have registration number. Correct now? You have register number when you join the college. College you have registration number and one more number is there. What is that?
Student ID.
No, we call it as roll number right now.
Roll number.
Roll number how they will create and register number how they will create. What is registration number? What is roll number? Registration number is, for example, you join BCA and your registration number is 1012. Another student come to the join the college. He is BSc. His roll registration number is 1013. Correct? These are different MCA. Somebody is joining at that date. The registration number is for them. Who came first? Who came second? Who joined? Right? But roll number is mainly for your class alone. Now, how they will write this roll number? First, they will arrange it in the alphabetical order here. Correct now? Then they will put the roll number 101, 102, 103, 104, like that. Now, what is the plus point of having this roll number as one? Another one is arranging this name into alphabetical order. Why we need both of these? Is it going to help you? Yes, arranging in the alphabetical order. That is
Yes.
called, yes, that is called sort key. I can able to find out the person easily by sorting it in the ascending order. I'll keep it so that I can able to use it. Now partition key is nothing but this primary key. This roll number become a primary key, and that is called partition key. And I join with this sort key. That is the next name is coming with sort key. It will arranged in the ascending order. Now both these two together we call it as compound key. That is partition key plus sort key. Okay, now here partitioning. So as I already mentioned, like in the DynamoDB, that is your NoSQL, we have two options. One is query by the key to find items efficiently. Another one is scan to find items by any attribute. That is scan means I want name column, and the name column I want this person. Like that we can able to mention it in the query. Scan means we have to scan all the items, all the attributes. I have to scan it, all the items I have to scan it. Query means I directly go and type that particular number, name, and everything. Now items in a table must have a key. So every table in the database especially, you should have a key. The primary key should be definitely there, or foreign key should be there. Now here you can see, as I already mentioned, first one is partition key, nothing but primary key. Second one is here only partition key we are mentioning. Here we can go for both partition key, that is your registration ID or something, and sort key, that is arranging in the alphabetical order. Now both these two together are called as compound key. Coming to the end of this section. So DynamoDB mainly run on SSD. As we already know, SSD means what? As I mentioned multiple times. So SSD is nothing but like your laptop, phone, whatever we have. Mostly it will be moving to SSD now. And it supports document and key value pairs to more store models. Replicates your tables automatically across choice of AWS region. So DynamoDB will help you to replicate your data in the region wise also. It works well mainly for your mobile, web, gaming, adapt, and Internet of Things application. As I mentioned in the previous one, it will be able to use for gaming mainly, and it is accessible via console and the command line interface and the API calls, API, CLI, and API calls. And it provides consistent single-digit millisecond latency. Just why I told you, millisecond latency means what? Your Instagram, it's very, very, very faster. Millisecond, it is loading everything, and that too at any scale. That is your, I think your Facebook also, you're able to see a full movie they are posting, I think so nowadays, or half of the movie. It is loading fast, and there is no limits on table size or throughput. Throughput means bandwidth. Throughput means bandwidth. I hope you understood. Fine. So we have two topics only. We'll see the Redshift tomorrow at the same time. Okay.
Sure.
Yeah. Okay. Yes. Fine. We'll see you. Thank you.
Thank you,
Uh,
Murli.
yeah.
Bye bye.
Thank you. Bye bye.